Welcome to Centum guys. Today we discuss exercise 1.2 from question number 1, class 12 Ncert. First already, show that the function f is such that r tending to r defined by f of x equal to 1 by x is 1 to 1 and on to, where r is set of all non-zero real numbers. So what is 1 to 1? If f of x equals to f of y, then x should be equal to y. Then it is called 1 to 1, or in simple terms, each and every element in set A has distinct elements in set B. So every element has unique images, that is called as 1 to 1. So onto is nothing but any element in set B is the image of set A. So if it is satisfied, this is onto. So in a simple term, we can say that if f of x equal to y, then the function is onto. So first we check for the 1 to 1. Okay, so let f of x equals f of y. So what is f of x? 1 by x. So f of y becomes 1 by y. So just to reciprocate, so what we got, x equal to y. So this is 1 to 1 function. So let's check for onto. So what is onto? First we substitute the given function as y. So 1 by x is y. So from this, what is x? X equal to 1 by y. So now let us substitute the value of x in the given function. So the given function becomes 1 by, what is the value of x? 1 by y. So what is 1 by y? So 1 into y by 1 equal to y. So we got f of x equal to y. So this is onto. So the given function is both 1 to 1 and onto in the set of real numbers. One more additional question has been given. Is the result true if the domain R is replaced by n, that is natural number, with the codomain being the same as R? So codomain is not changed, but the domain is changed from R to natural numbers. Fine. So now let us check for the 1 to 1. Let f of x equals f of y. So 1 by x equals 1 by y. So x equals y. Therefore this is 1 to 1. So checking for the onto. So for example, if we take 1 by x as some real numbers, for example 1.5, okay, then x becomes 1 by 1.5. So what is 1 by 1.5? 1 by 3 by 2, that is 2 by 3. Okay, so this is real number, but this is not a natural number, because what is the domain given? Natural number. So for any input of the real number, we are not getting the natural number. So this is not onto. So the result is not true if the domain R is replaced by n and with the codomain being the same as real numbers. Coming to the second Arabic, check the injectivity and surjectivity of the following function. So injectivity is nothing but 1 to 1 and surjectivity is nothing but onto. So if the function is both injectivity and surjectivity, then the function is called as bijective. So the first Roman is f is such that n tending to n given by f of x equals x square. So what is the domain given? N. Okay. So let's check for 1 to 1. So let f of x equals f of y. So what is f of x? X square. So f of y is y square. If we take square root, we will get x equal to y. So this is 1 to 1. Okay, because for any value of natural number, so x equal to y becomes same, which means x and y are the same values. Fine. So checking for the onto. Okay, for example, if we substitute x square equal to y, then x equal to square root of y. Okay, so we substitute any natural numbers. So x square equal to 2. Then x equal to square root of 2. That is 1.414 something. So this is not belonging to the given domain. Okay. So this is not onto. So coming to the second Roman, the function is same, but the domain is changed from n, natural number, to integers. Fine. So what is integers? All the whole number and its negative including 0. Okay. So first we will check for the 1 to 1. For example, if f of x equal to f of y, that is, we will take randomly some value. So f of 1 is 1 square is 1 because f of x is x square. What is f of minus 1? So minus 1 whole square, we got 1. So f of x becomes f of y, that is f of 1 equal to f of minus 1. But we should get x equal to y, right? X is 1, y is minus 1, right? So x is 1, y is minus 1. So x is not equal to y. So this is not 1 to 1. So checking for the onto, okay, so we will take any integers. Okay, the given function is x square, so we will take any integer minus 3. Fine. So then x becomes square root of minus 3. So this is an imaginary number, right? So this is an imaginary number and this does not belonging to the integer. So this is not onto, which means this is not surjective. Okay, this is not 1 to 1. So 1 to 1 means it's not, this is not injective. Okay, so this is not surjective. So what is the third Roman? F is such that R tending to R, that is domain and codomain. So f of x becomes x square, the same function. So let's check for the 1 to 1. Okay, so we have to take a value such that f of x equals f of y. So we will take x equal to minus 2, 2. Fine. So f of minus 2 is minus 2 whole square, that is 4. F of 2 is 2 square, that is 4. Okay, both we got same value, that is f of minus 2 equal to f of 2. So this is x, this is y. X equal to minus 2, y equal to 2. But x is not equal to y, being f of minus 2 equal to f of 2. So this is not injective. Fine. So checking for the surjective. So injective is over. We will check for the surjective. We will take some value for x square in the set of real numbers. For example, minus 4. Then x becomes square root of minus 4. That is, it is not belonging to the R, because it is an imaginary number, so it's not belonging to the real numbers. Therefore, this is not surjective. So in fourth Roman, f is such that n tending to n given by f of x equal to x cube. So the domain is natural number, the function is x cube. So we check for the injective. Okay. So if f of x equal to f of y, then x cube becomes y cube. So if we substitute any natural number for x and y, that is x and y should be the same. So we will get x equal to y. So this is injective. So checking for the surjective. Okay. So we will take some natural number, okay, 6. Then x becomes cubic root of 6. Of course, this is a decimal number or irrational number, and it is not belonging to the domain natural number. So this is not surjective. In fifth Roman, f is such that z tending to z given by f of x is x cube. The function is same, the domain is integers. Fine. So let's check for the injectivity. Okay. So we cannot have two different numbers where we get f of x equal to f of y. Right. So if you take 1 comma minus 1, we will get different value. So we cannot have two values, that is x and y, where we get f of x equal to f of y. So we cannot have two values where we will get f of x equal to f of y, because if we substitute 1 and minus 1, we will get different f of x and f of y. So in general, x and y should be the same. So x cube equal to y cube, then x becomes y. So this is injective. So checking for the surjective, so let x cube becomes some integers. So x becomes cubic root of minus 5. So of course this is not belonging to the given domain. So this is not surjective. Thanks guys, like, share, comment and subscribe.